Hello, my dear WAEC Physics learner. Let's solve this peacefully together. We are looking at question 13 from the 2026 WASSCE, and our objective is right at the end. Calculate the quantity of heat released. Whenever a question asks for the quantity of heat involving a temperature change, use this formula. Q equals mcΔθ. Q is heat energy, m is mass, c is specific heat capacity, and delta theta is the change in temperature. Solving this is a matter of accurately identifying which values from the text fit into these four specific variables. Let's pull the data directly from the prompt to build our list. The mass is 100 grams. The specific heat capacity is 460 joules per kilogram per Kelvin, and our starting temperature is 70 degrees Celsius, falling to a final temperature of 20 degrees. We have to be careful right here. Look at the unit for specific heat capacity. It is measured per kilogram, but our mass is currently given in grams. To fix this, we convert grams to kilograms. Since 1,000 grams make 1 kilogram, we divide 100 by 1,000, leaving us with a mass of 0.1 kilograms. Standardizing these units first is essential. Missing this step leads to an answer that is incorrect by a factor of 1,000. Next, we need our change in temperature, or delta theta. The metal cools from 70 down to 20, so we subtract 20 from 70, which gives us a difference of 50 degrees Celsius. Since a temperature difference in Celsius is the same size as a temperature difference in Kelvin, our change is exactly 50 Kelvin. We have our clean variables. Before I show the final steps, hit pause. Try multiplying these numbers yourself and see if you can match one of the options. Let's plug them in. Q equals 0.1 times 460 times 50. Multiplying gently, 0.1 times 460 gives 46. Then 46 times 50 gives us a raw energy output of 2,300 joules. Our options are written in standard form. To match them, we move the decimal 3 spaces to the left. That gives us 2.3 times 10 to the power of 3 joules, which is option A. Converting to standard form at the very end ensures your final result aligns with the multiple choice options provided in the exam. Let's lock this down. For any specific heat problem, follow these 4 steps. 1. Convert your grams to kilograms. 2. Find the temperature difference. 3. Multiply Q equals mcΔθ. And 4. Remember a falling temperature means heat is released. Let's test that. Quick quiz 1. A 0.2 kilogram metal with a specific heat of 400 cools from 60 to 40. The mass is already in kilograms. The difference is 20. So Q equals 0.2 times 400 times 20, giving 1,600 joules. Quick quiz 2. Mass is 200 grams, specific heat 500, temperature change 10 Kelvin. First, convert 200 grams to 0.2 kilograms. Multiply 0.2 by 500 by 10, and you get 1,000 joules. Excellent work. The final answer for question 13 is option A. For more in-depth practice ahead of your exams, visit QandAHelp.com. And don't forget to subscribe to this channel for more step-by-step solutions. Methodically checking your units and following a consistent workflow makes these calculations much more manageable. Happy studying!